If you're keeping tabs on industrial automation, you've probably bumped into terms like distributed industrial process measurement and control systems.
Where?
They sound pretty complex, right? And, well, they are. But what if I told you there's an open source way in, something making this tech surprisingly understandable and even pushing innovation? Today, we're diving deep into Eclipse 4diac. It's this open source framework based on the IEC 61499 standard. I think you're going to find this really interesting.
Absolutely. In this deep dive, it's really your shortcut, a way to grasp how the tech behind modern automation gets built, managed, and how it's changing. What's really key here, I think, is how open standards, especially through tools like 4diac, are paving the way for the next generation, making things, way more flexible and accessible.
Right. So our mission today, let's unpack 4diac. What is it? What are its main parts, its history, and especially its development environment, the 4diac IDE? What makes that tick? Okay, so let's just jump right in. At the most basic level, what is Eclipse 4diac? The source describes it as an open-source infrastructure for distributed industrial process measurement and control systems based on the IEC 61499 standard. It's quite a bit to chew on.
It is, yeah. Let's simplify. Think of 4diac as a free toolkit, like a common language and set of tools for these complex industrial systems. The distributed part, super important. It means parts of your system can be spread out, different machines, maybe even locations, but they act as one single system.
Okay, working together even though they're separate.
Exactly. And that IEC 61499 standard bit, that's the rule book, the common ground. It ensures everything can talk the same language, gives you flexibility, interoperability, regardless of the hardware underneath. And the sources really emphasize this. 4diac isn't just theory, it's proven itself. It's a stable base for research, for figuring out the next generation of automation using these open standards. It's like a foundational.
Foundational, I like that. A bedrock. And what's really smart, I gather, is that 4diac isn't just one thing. It's more like a whole ecosystem.
That's spot on. Yeah, it's a full suite, designed to cover everything, from designing the system to actually running it. You've basically got four main pieces working together. First, the 4diac IDE. That's your integrated development environment, where you actually design things.
The drawing board.
Pretty much. Then there's 4diac 4T. That's the runtime environment. Think of it as the engine making your design actually run on the hardware.
Okay, design and run. Got it.
Then you have 4diac lib. That's the function block library. It's full of reusable bits of code, like digital Legos you snap together to build your logic.
Pre-built components saves time.
Exactly. And finally, 4diac SYS. This provides example projects, really handy starting points, especially if you're new to it or tackling a specific type of problem. So yeah, all four work together for a complete solution, start to finish.
Right, so putting this all together, what does this actually mean for you, the listener, maybe working day to day with these systems? Let's zoom in on that 4diac IDE, the design part. What's its core idea, its philosophy?
Okay, the IDE. It's specifically built as an IEC 61499 compliant development environment. And crucially, it's based on the Eclipse platform. Now, that's important because Eclipse is huge, it's extendable, so 4diac can easily plug into other tools, add new features. It's built on a solid, adaptable foundation.
Okay, so it's not isolated. It leverages a bigger ecosystem.
Precisely. But its core philosophy, the really big idea, is application-centric design. This is kind of a mind shift. It means you think about and build the overall application first, what your system needs to do often before you even know the exact hardware. You design this by interconnecting the desired function blocks, FB, in terms of a function block network, FBN.
Hold on, function blocks, FBSB, those are the digital Legos you mentioned.
Yes, exactly. Think of them as little packages of industrial logic, reading a sensor, controlling a motor, a safety check, things like that.
Okay, and the FBN, the network, is how you connect them visually.
You got it. It's visual programming. You drag, drop, connect the blocks to build the entire logic flow. Only after you've designed that application logic and the hardware structure is known, then you distribute that logic onto the actual devices.
So logic first, then hardware mapping.
Exactly. It decouples the what from the where. That separation gives you massive flexibility. You can reuse logic, adapt to new hardware much more easily. It's really powerful.
Wow. Yeah, I can see how that would be a game changer. Designing the what before worrying about the where.
So, okay, this IDE sounds central. What are the specific tools inside it? How does it help you actually design, deploy, and, importantly, debug these things?
Right. It's definitely a complete workbench. It has tools for each step. You'd start with the System Explorer. That's for managing your whole project. The applications, the system setup, any custom libraries you create.
Your project overview.
Then the main event is the application editor. That's where you do the visual design, connecting those function blocks into networks, the FBNs we talked about.
Okay, drawing the logic. What about the physical side?
For that, there's the hardware editor. This is where you tell the system about your actual hardware, your controllers, your input-output modules. You model them as IEC 61499 devices and set their parameters.
Defining the physical setup. And if you need custom Legos, custom function blocks. Good question. That's where the type editors come in. You can create your own function block. There are a few kinds. You've got basic FBs, BFD for fundamental logic, maybe coded in C++. Then composite FBs, CFB, which are like mini networks built from other blocks. There are also service interface FBs, SIFB, which are key for talking to things outside the standard IEC 61499 world, like databases or specific communication protocols. And adapters help connect components that might have slightly different interfaces.
Okay, so tools for creating basic blocks, combining them, and interfacing with other stuff. You design the logic, define the hardware. How do you link them?
That's the job of the distribution editor. Once your application logic is ready, you use this tool to literally drag and drop parts of your function block network, or even single blocks, onto the specific hardware resources you defined earlier.
Ah, the mapping step.
Yeah.
Makes sense. Then you need to get it onto the actual devices.
Yep, that's deployment. You can selectively download the right application parts to the right controllers or devices. And of course, things don't always work perfectly first time, so you have monitoring and debugging functionalities. These let you watch the data flowing between blocks in real time. You can even force values to test things or trigger events manually.
Essential for troubleshooting.
Absolutely. And there are also dedicated testing functionalities. You can really drill down into individual block behavior, set breakpoints like in traditional coding, step through logic execution, manually input data. It's quite comprehensive. So you see, it's really this integrated environment. It takes you all the way from concept to running tested code on hardware, much smoother than juggling separate tools.
That integrated approach sounds incredibly valuable. Okay, stepping back from the tools themselves, 4diac has a history, right? It wasn't just born yesterday. It was founded to support research activities and industrial adoption. How has it evolved? And what about the community around it?
It really has grown steadily. It's matured a lot over the years. You see consistent updates, new versions, improvements, adding new features for modeling these systems. One big focus, the sources mentioned, has been performance improvement of the runtime system, making Forte run faster and more efficiently on the hardware, which is critical in industry.
Faster is always better in controls.
Always. And this constant development reinforces its role. It's seen as that stable platform for research into, what's next for distributed control based on open standards. And the community aspect is strong. They actively engage. For example, there's a first 4 days of Eclipse 4diac Winter School planned for 2025. That shows investment in training and bringing people in.
A winter school. Interesting.
Yeah. They also hold regular Eclipse 4diac virtual community meetings to keep everyone connected. And they had a bigger 4 days of 4diac event back in 2019. Plus, looking back, there was a whole series of ETFA workshops that's emerging technologies and factory automation focused specifically on 4diac. They ran from the first in 2010 up to the 7th in 2016. That shows real, sustained engagement over many years.
That longevity and consistent community support definitely speaks volumes. So for you listening, maybe your interest is piqued. Maybe you want to try this out or even contribute. What resources are out there?
The good news is there's a lot, and it seems really well organized. On their site, under Getting Started, you'll find basics like the documentation start page, specific info to learn about IEC 61499 itself, and material to understand the whole 4diac framework.
So foundational stuff first.
Right. Then, for actually using it, under Using Eclipse 4diac, there are step-by-step tutorials, guides for installation, examples built right into the IDE, and a helpful FAQ section.
Practical guides. Nice. What about more advanced topics?
Yep, there's a details section that gets into things like I/O configuration for specific hardware platforms, different communication protocols it supports, and even how to get involved in developing 4diac, 4TA, or the IDE itself if you're feeling ambitious. And importantly, they have very clear support and contribute pathways. So whether you need help or want to give back, it's easy to find out how.
Excellent. So lots of resources available. Okay, what a journey. We've really unpacked Eclipse 4diac, this open source, IEC 61499 infrastructure that's clearly playing a big role in distributed industrial control. It's this whole ecosystem aiming for flexibility.
It really is. And it leads to this final thought, maybe for you to chew on. Considering 4diac's whole philosophy, that application-centric design, where you build the logic first, refine it before you map it to hardware, what potential does that truly unlock? How much faster could innovation happen in automation if you have that kind of flexibility, that ability to adapt quickly as technology changes?
A really powerful question to end on, something to definitely think about the potential impact of separating the what from the where in the future, all these connected industries. Thanks for joining us on this deep dive.